muscles. We use muscles for a multitude of things. We use them to blink, laugh, eat, and much more. Here are a few vocabulary words.
Epiphysium, the connective tissue generally extends beyond the fleshy part of the muscle, forming a thick rope-like tendon or board. Paramecium is a name given for the fibrillous sheath that surrounds each bundle of single muscle fibers. Vessel is a bundle of structures such as a nerve or muscle fibers or conducting vessels in plants. A small bundle of nerve fibers enclosed by the paramecium. Endonesium, when there are high concentrations of calcium ions, the tropomyosin gets displaced, thus allowing the binding sites. The neurotransmitter transmits signals to muscles so they contract.
Imagine this. You get 100 pencils, which represent muscle fibers. You wrap each individual pencil in dense tissue paper. This is the endomysium. Then you take 10 pencils and put them in a bundle, which would be a fascicle, and wrap them in paper. This is the paramecium. Next, you will take all the bundles and wrap them together with gift wrap. This is the epimecium. Finally, you're going to wrap it in brown paper, which will be the fascia. Okay, so this is how the sarcomere looks like. This would be the myosin, which is the thick filament, and this would be the actin, which is the thin filament. The myosin is connected to the M line right here, which is also right here, as you can see. And this would be the Z line, which is connected to the actin, which is right here, as you can see. So this is how it works. Whenever there's a high concentration of calcium ions, one of the calcium ions will connect to the troponin, thus causing the tropomyosin, right here, to contract closer to the actin, causing the binding sites to be revealed, allowing the myosin to be able to bind to the binding sites, thus binding sites. And one of the ATPs that come over here will turn into ADP, and it will allow the myosin, these little filaments right there, well, this is an entire myosin, but the little filaments that are on the myosin, they will connect to the actin, and they will be able to move the actin along closer to the M line. And in order for these little lines to relax, another ATP has to connect to them, and it'll turn back into ADP, and then it'll connect again back over to the actin proteins, and they will keep moving. And that's it. Think of it like this. The myosin filament is this swimmer going through the water, and the water is the thin filament, the actin. The arms of the swimmer are what binds the myosin to the actin, thus causing the actin to be moved towards the M line. Another example would be tug of war. The kids are the myosin and the rope is the actin. The kids are trying to pull the actin towards them. Without the ability to contract muscles, we wouldn't be able to do very much.